Okay, so this is going to be the start of our new unit. So under the topic, you want to write Unit 7 factoring, and then don't forget to put your name on it as well. So factoring is essentially just the opposite of multiplying. We were kind of working backwards from multiplication. So as a reminder, this is how we were multiplying earlier in our previous unit, is we would make this box. So I'm multiplying a times 3a plus 7. I would make this box to multiply. A times 3a would give me 3a squared. And then a times 7 would give me 7a. So this would give me 3a squared plus 7a. Okay, and then for this one, I would do negative 2m in front, and then m squared plus 6m minus 1 on top. Okay. Negative 2m times m squared would be negative 2m cubed. Negative 2m times 6m would be negative 12m squared. And negative 2m times negative 1 would give me 2m. So this would be negative 2m cubed minus 12m squared plus 2m. Okay. And finally, we'll multiply this one. This is 4x cubed y times x squared minus 2y. So multiplying these together, this would give me 4x to the 5th y, and then negative 8x to the 3rd y squared. So hopefully that looks familiar to you, because this is what we were doing in our last unit, just kind of a quick refresher to help you re-familiarize yourself with it. So that was what we were doing in our last unit. In this unit, we're going to be going the other way around. So instead of starting with this a times 3a plus 7 and getting the answer of 3a squared plus 7a, we'll be starting with something like 3a squared plus 7a, and our solution, our answer, is going to be the a times 3a plus 7. Okay. So we're doing the same types of work with the same types of problems, but essentially it's going to be going backwards. Sorry, it looks like it reset on me, but I will re-put those back on there. 3a squared plus 7a would become a times 3a plus 7. Okay. So that's all we really need to look at for the top. I'm going to go down to these example problems on the bottom and kind of show you some examples of how we're going to be going through these. So as always, I will be working through some of the problems on the left. You guys will be working on the problems on the right on your own. So for number 1, we have 3x plus 12. First thing that I want to do is try to find whatever factors that these two terms would have in common. So the way I can do that is if I go to the very last page of my packet, or you should have a loose copy of this as well, I'm going to be looking for 3 and for 12. So if I find 3 and I find 12, here's a list of all the numbers that I can multiply together to get 3 and 12. And I'm going to write those on the problem underneath these numbers. So 3, I can multiply 1 times 3, and that's really the only option. Or I could do 3 times 1, but it's 1 and 3. For 12, there's some more options. 1 times 12, or 2 times 6, or 3 times 4. Any of those options would give me 12. Okay, so I'm going to go up and write these on the problem underneath 3 and 12. 3 is 1 times 3. 1 times 3. 12 is 1 times 12, or it could be 2 times 6, or it could be 3 times 4. Okay. Also, to get this 3x term, I need to have x as well. So once I know everything that I need to multiply together to get these terms, I'm looking for the biggest thing that I see in both parts. So I see that they do both have a 1, but they also both have a 3. And I want the biggest one that they both have. So the one that I'm going to go with is the 3. because that's the biggest one that they both have. We're looking for the greatest common factor. Greatest means biggest. So 3 is going to be what they have in common. Okay. Then, once I know what they have in common, what I'm going to do is essentially, in this set of parentheses, take everything that's left, excuse me, everything that's left when I take out that 3. So if I take this 3 out, what's left is I have a 1 and an x. So that would give me 1x. And then for the 12, when I take out the 3, what's left with the 3 would be a 4. Okay. In between these is going to be the same symbol that I have in the problem. So this was a plus. This will give me 3, and then 1x plus 4. So now on to number 3. We have 8m plus 36n. So the numbers I'm going to be looking for are 8 and 36. So again, I would turn to this page, and I'm finding 8 and 36. Here's our numbers that would multiply to get those. So I'm going to go up and write them on the problem. 8 is 1 times 8, or 2 times 4. 36 is 1 times 36, or 2 times 18, or 3 times 12, or 4 times 9, or 6 times 6. So 36 has a lot of different options. Okay. The 8m also has an m. The 36n also has an n. So now we're looking for the biggest thing that they have in common. Let's see, they both have a 1, they both have a 2, I see they both have a 4. That looks like the biggest thing that they have in common would be that 4. So I'm going to start with 4. That's the biggest thing they have in common. If I look at the variables, one has m and one has n, so they don't have the same variable. Those would not be in common. So then I take the 4 outside of the parentheses, and whatever's left over is going to go inside. So when I take out this 4, I have a 2 and an m left over. So that would be 2m. And then when I take out the 4 from the 36, I have a 9 and an n left over. This would be 9n. And again, since this is a plus sign here, this will be a plus sign as well. Okay, so go ahead and turn the page, and we're going to continue on the back side. So number 5, we have 6a squared plus 27. Again, I would go find those numbers on the paper, but I'm not going to go show you that at this point. So 6 would be 1 times 6, or 2 times 3. And then the a squared would have 2 a's being multiplied together. That would be a times a. 27 is 1 times 27, or 3 times 9. So I got to look and see what is the biggest thing that they both have. I see they both have a 1, and they both have a 3. So 3 is going to be that biggest common factor. Okay, looking at the variables, they don't have the same variable, because the 27 doesn't have a variable. And so the only thing in common that they would have that we can take out is that 3. When I take out the 3, I'm left with a 2, and then these 2 a's, so it's going to be 2 and a squared. And then when I take out the 3 from 27, I'm left with 9, and this will be a plus. Okay, number 7. I've got 21 and 3, so I need to find the numbers that multiply, 1 times 21 or 3 times 7. For 3, it's just 1 times 3. This one, CD, has C times D, and this one has D. Okay. So looks like the biggest thing that they have in common would be 3. So looking at the variables, they also both have D. So if they both have a D, we need to put that in front as well. So now we look at what's left over. When I take out the 3, I have a 7 and a C left over, so that would be 7C. And then over here, I have a 1 left over, so it would be a 1. And this one, because it's a minus, will have a minus in the middle. All right, number 9. Numbers to multiply to 15 are 1 times 15, or 3 times 5. Numbers to multiply to 30 are 1 times 30, 2 times 15, 3 times 10, or 5 times 6. The a squared b would be 2 a's and a b, and the ab would be a and b. So looking at these, they're going to have a lot of numbers in common. They both have 1, they both have 3, they both have 5, but the biggest one that they both have is 15. So we all got to make sure we're getting the biggest one. I also see that they both have an a, so I'll put an a with it, and they both have a b, so I'll put a b. Okay, then we have to see what's left over. What's left over with this 15 is a 1 and an a, so I put 1a. And what's left over with this 15 is a 2. And this is a minus, so this down here will be a minus. Okay, number 11. This is a b minus a. Remember, whenever there's not a number in front of our term, this would be a 1. So it would be 1ab minus 1a. 1 is 1 times 1. So both of these would have 1 times 1. And ab would be a times b. This a would just be a. So what it looks like they have in common is a 1 and also an a. So they would have 1a in common. Then what's left over is the 1 and the b for the first term, so 1b. And then what's left over for the second term is a 1, and a minus would go in the middle. Okay. Now remember, we don't actually have to put all these ones. If it's 1a or 1b, we don't have to put that. You could write it as just a and then b minus 1. You don't have to put the ones in front if you do not want to. But either one of these would work as your final answer. Okay, so number 13. We have 5x, so that would be 1 times 5 and then x. And then 13y, that would be 1 times 13 and then y. So in this case, the only number that they have in common is 1. And they don't have any variables in common because they have different variables. So the only thing that we could put in front of the parentheses would be a 1. When that's the case, if the only thing we can take out is a 1, what we're going to have left over is going to be what we started with. We'd still have 5x, which is what we already had at the beginning. And then we have 13y, which is again what we had at the beginning. And so that doesn't actually change anything. So if the greatest common factor is a 1, we don't actually have to do that greatest common factor part. We can just leave it as it is. So this would just stay as 5x minus 13y. Okay, we're getting towards the end of the notes. Number 15, we have 3 terms here. So we have to make sure that whatever is in common for all 3 of them. So this 2x squared y, 2 would be 1 times 2, and then the x squared would be x times x, and then we have that y. This 2 would also be 1 times 2, and then we have x and y times y. And then for the 4xy, we'd have 4 times x times y. Okay, oops, sorry. The 4 has more options than that. So 4 would be 1 times 4, but it would also be 2 times 2. Now we need to find the biggest thing that they have in common. Looks like they all have a 2, and that's the biggest thing that they all have. Excuse me. So they all have a 2 in common. I see that they also all have an x, so I can take an x out. And I also see that they all have a y, so I can take a y out as well. Okay. Then I look at what's left over. That would be 1x here. I'm going to put just x, but you could put 1x. This, for the middle term, it'd be 1y, so I would, again, just probably put y. This one will be a minus. And then finally, for this one, when we take out the 2xy, we're left with a 2. And this one is a plus. So we get 2xy and then x minus y plus 2. Okay. Number 17. We again have 3 terms. The 6y to the 4th, that would be 1 times 6 or 2 times 3. And then we'd have 4y's. So the 14y cubed would be 1 times 14 or 2 times 7. And then there's 3y's. And for the 10y squared, it'd be 1 times 10 or 2 times 5. And then we have 2y's. So we're looking at what they have in common. They all have a 2. Okay, they also have at least one y. Okay, so I can put a y. I also see they all have at least one more y. So they all have at least y squared. But I can't take out any more because we don't have any left over here. So we're going to take out 2y squared. And then what's left over is 3y squared for the first one. 7y for the middle one, and this one will have a plus. And then 5 for the last one, and this one will have a minus. So that will be my final answer, is 2y squared times 3y squared plus 7y minus 5. The last 3 I will not be doing on this video, but they are posted onto Canvas if you would like to see the work done for number 19, 21, and 23. Your assignment is to finish all the ones that are on the right side. So all these even problems, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. So once you get through this one, you are done.